Hi all, this is series 12. In this series, we will discuss on the generative AI use cases on AWS. I have selected a few use cases in this series, and I will cover some more use cases in the next series 13. So this is the part 1 for this series, and here we will discuss on this series 12 what we will cover, and later I will cover some introduction portion of generative AI and introduction of the LLM models, right? So agenda for this discussion of the series is mainly this is divided in the 4 part. So I will cover 4 videos part for this, and this is the first part 1 where I will give the brief introduction of this series. So in the next part for this series, we will discuss on the chatbot creation, and basically in all part 3 and part 4 also we will create the chatbot, but this is a process are different for all 3 videos. So I am taking the different services, you can say LLM models for that. So in the first part 2, I will cover this generative AI application builder on AWS. Using this functionality of AWS, I will create the chatbot using the Bedrock and Amazon Kendra as a knowledge base. And Kendra will be connected with that S3 using the connector, right? So this all those deployment in part 2 will happening with the CFT cloud formation template, and you can say we will not use any code deployment creation of any code over there, right? So you can see it is a no code so in the part 2, and later in the part 3 we will create a chatbot within the Bedrock, and we will use vector DB as a knowledge base. So in vector database, it will store the embeddings, and we will discuss in this part 3. And in part 4, we will use that chatbot, create the chatbot using the SageMaker jump it start. Actually, this difference is only that here we will use the Bedrock, and here in part 4 we'll use the SageMaker jump start for the. So this is using some LLM models for Bedrock, and some LLM models already available for the jump start. Some are the common, and but jump start SageMaker contains the more LLM models. So we will take that LLM model from the jump start and using the same vector database as a knowledge base, right? So motive is here for doing those. We can use the different services for the AWS like Bedrock and other services for SageMaker for Jumpstart also for that demo. So we will cover three demo in this series, and basically difference between Bedrock and SageMaker. You can say at high level it is Bedrock is a serverless, and SageMaker Jumpstart is a compute based, right? So we will create 3 demos in this series, right? Part which will come in the part 2, part 3, and part 4, right? So what is the prerequisite for this lab? At least AWS knowledge required, AWS account is required, GitHub account is required, basic knowledge of AWS, ML and AI is required, right? And GitHub repository, this is my personal account for repository, but this is a public repository for that Gen AI use cases. And I will put all those document and other important files over there, so which you can get it from this location itself, right? Now we will discuss what is the generative AI. Generative AI means creating new data. Generative AI is a branch of the AI that focus on creating the new data. And generative AI is a subset of machine learning. You can say subset of deep learning, and deep learning is subset of machine learning, right? The goal of generative AI to create a new data that is similar to the data set used for the training the models. So it means generally what is the training data we are using for train the model. That similar way we will get the output for that. As is the old ML models, we are doing the same thing. We are generating our data set for the training purpose and train our model, and based on that we are getting the output on that. But in the generative AI use cases, you are using the LLM models. It means they are pre-trained model for that. We will discuss in the next slide for that, right? So AI that can generate the contents that is, you can say, closely to the human generated content, similar like that we are getting from the AI itself. And it is applicable to multiple use cases like text summarizations, question answering, digital art creation, code generation, etc. Like that, multiple use cases we have. I will show you later in the slide multiple use cases in different domains itself, right? And it is powered by the foundation models. That means it is already a pre-trained models on the large data set, and with several hundreds billion parameters are already there. So it means we don't need to train our models and our foundation model anything. We just pick up those model directly and use it. But we have another functionality here. We can do fine tuning on that. We can do fine tuning based on the specific domain knowledge, right? Any specific domain requirement, we can do it. So using this, it is reduce the time and cost associated with the developing ML models. Like in the earlier in the ML models, we are creating the data set and we are creating train the models, those required commute and hardware for that, right? That we are spending time and cost over there. But in this generative AI LLM models, we don't need to do those things for that. This is the generative AI application examples. Like in communication sector, you can say this example is chatbot, question answering, and search. Similarly, in multiple domains are there and different uses I have collected here. That is technology, hardware, financial services, automotive, consumer goods, healthcare, and media and entertainment. There are different type of industry where we are using different type of application examples are there. So we can apply generative AI in those places here, right? So what is the LLM, large language model, right? So you can see here, this is a machine learning, and deep learning is a subset of machine learning, and Gen AI is subset of deep learning, and LLM, this is a large language model, is also a subset of the deep learning. Large language models are the pre-trained, as I told earlier, this is a pre-trained and the massive data save thousands of parameters we already trained to those models for that. And it uses the deep learning techniques for that. And we can fine tune again this LLM model as per the specific parameter, specific domain, we can do it, right? So that is a difference between the LLM development versus a traditional development. So earlier in the traditional ML developments, what we're doing, we are required the machine learning expertise needed. That means we need some training data. We need to create those things. After that, we need to train a model. Then for training those model, we required some compute time and also hardware is required for that, right? But here in the large language model development, we don't need any machine learning expertise for that, right? No training examples or data are required for that because these models are already pre-trained for that, right? and no need to train the model for that. This is the basic difference for those LLMs and old traditional models for that, right? So these are the types of the foundation models. So it is basically categorized in the text for the text generation, image for the image generation, right? And other types are dialogue, code generation, and completion, like code whisperer models there, embeddings are there, right? So, but in this demo, we will discuss on the text type of foundation model, right? So in this series, actually, I have covered only this types of model, but later in the future series, I will cover other types of foundation model also, right? So this is the brief introduction I've given for the generative AI and LLMs. And the next part of this series, we will discuss on the generative AI application builder in AWS, where we will go and deploy the chatbot using the Bedrock and Kendra, right, as a knowledge base for that. So in this second part, we will discuss on that this generative AI, and also I will show the demo how to create those things, right? So if you like this video, please like and subscribe my channel, and we will meet you in the next part for this series. Then bye.